and today I have brought the chapter of physics, and that is force and laws of motion. So first we will start from the force, balance force, unbalanced force, effects of force and friction force. So let's start with the force. What is force? Generally we have studied in the lower classes that the push or a pull is called force, but that is not exact definition for the force. Actually, there is no exact definition for the force, but we generally call a push or a pull is called force because the push or a pull can only cause force. That's why we have studied in the earlier classes a push or a pull is called force. But that is not correct. You can remember this. Now balance force. What is balance force and what is its function? Now we will learn. So this is an object. It is on the table. 10 Newton force is applied from this side and 10 Newton force is applied from this side. So what will happen? Will this object move or not? No, because the same force is applied from here and same force is applied from here. That's why the object will not move in any of the directions. So this is called balanced force. Balanced, 10 Newton here, 10 Newton here. So balanced force. The name is also suggesting it. So balanced force cannot move an object. It can only help an object to stay on its own position. This is what called balanced force. Now we will learn about unbalanced force. What is unbalanced force? Just opposite of balanced force. 10 Newton force is applied from here and here 30 Newton force is applied. So what will happen? The object will move in this direction. Object will move in this direction. Why? Because here the force applied is more than force applied here. That's why the object will move in this direction. This is what called unbalanced force. Unbalanced force always causes the motion in an object. When unbalanced force is applied, it always causes motion of the objects. Now we'll learn about the effects of force. What are the effects of force? For this, I have to tell you one thing, that we cannot see the force, taste the force, or we cannot hear the force, but we can see the effects. What are these effects? Effects of force. We can see only the effects. What are the effects of force? We can feel them. We cannot see. So, effects of force. So, when an object is moved from one direction to another, suppose this is an object and it is at the rest. When the force is applied from this direction, then it starts moving in this direction. Now what will happen? We can see the effect of force, that the motion of this object is due to this force. So effects of force are: number 1, force causes change in speed. Force causes change in speed. Force always causes change in the speed. An object is traveling in the from the speed of 10 meter per second. So when the more force is applied, it can move with the speed of 30 newtons or 40 newtons, 50 newtons, etc. So we can change the speed of the force. Force can change the speed. Number 2, force can change the velocity. Force can change the velocity of an object. Speed and velocity are same. So force can change the speed and velocity. Now 3. Force can change the shape of an object and size of an object. Force can change size. Number 4. Force can change shape. It can change size and shape. How? Suppose that you are having a clay. You apply force. What will happen? It will change the size from a big ball to a small flat surface. So, and what is the meaning of size? When force is applied, suppose you are having an apple and you are cutting it. What will happen? Force is applied and changing size. So this what happens in the plants also. When fruits are little bit small and then grows up and they are very ripe and tasty sweet. So force can change the size or shape, velocity and speed. So these are the effects of force. Now what is friction force? Friction is the special type of force which always opposes the motion. How? Suppose, now this is an object. Look it carefully. This is an object. Force is applied of 40 newtons. 40 Newton force is applied from this side. So obviously it will move in this direction only. It will move in this direction. But the friction force always opposes the motion. The object will move in this direction, but friction force will apply on this direction. Friction force. Friction force will apply on opposite direction. The object will move in this direction, but friction force will move in this direction. So friction force always opposes the motion. Now you might be thinking that if every object is opposing the motion, friction force is opposing the motion. So when we walk, then the earth will not move. Why? Earth will not move, when will move. So what happened in this case, that when we are walking, we are applying a force on the ground. We are applying a force on the earth. But the earth does not move because the mass of the earth is very high mass. It is having a large amount of mass, that's why we cannot see the earth moving from this direction. This what happens. Instead of moving the earth will not move. The earth will not move because the mass of the earth is very much in comparison to ours. So what happens here? The friction force is applying on the earth. But what happens in the return? We move forward. The earth will not move backward, but we will move forward. So this what happens. This is called friction force. Friction force is a special type of force. Now there must be some there are some advantages of friction force. So let's see what are the advantages. When we walk, the friction force is applied on our shoes. That's why our shoes worn out, our shoes tear. Why? Because friction force is applied on the surface of the shoes. You might be noticed that when the new made road, when the vehicles move on the new road, which is just 2 or 3 days may. So the road is very smooth. But after a year, you can observe that the road is rough now. Why? Because the motion of all the vehicles on that road make the friction force applied on the road surface of the road make the road rough. So there are some advantages. These are some advantages. You can also take our shoes. If the friction force is not applied on our shoes or the surface of the shoes, then we will not have to buy any of the new shoes. We cannot buy any of the new shoes because the old shoes cannot worn out or tear. Because of the friction force this happens, and this is the advantages for buying new shoes, fancy shoes. So now we will come to the next. Now we will learn about the first law of motion, second law of motion and third law of motion. These are the 3 laws of motion which are most important in this chapter. So what is the first law of motion? According to Newton, an object wants to remain in the rest, and an object which is moving remains in motion until an external unbalanced force is applied on it. The object wants to remain at rest or in the state of motion until an external unbalanced force is applied on this object. So what does it mean? An object is moving. Suppose this is a bus and it is moving in this direction. So it wants to move only in this direction. It wants to move. It does not want to be in the rest. It wants to move. It wants motion. So when we will apply the force, or when the driver will apply brake, then it will stop. External force. The brakes are the external force, and those are unbalanced, because when this is balanced force, then it will not stop. Unbalanced force, external unbalanced force is applied, then this object will move. Stop. Suppose this is an object and it is at rest. So it wants to be in rest. It does not want to be in motion. When we are tired, we want to just rest. We do not want to move any from here to there or there to here. So we just want only rest. But when our mamas just scold us and why are you lying here and there, then we have to move. We have to move. So this is an external unbalanced force which is applied. Then this object will move. So I hope you have pretty bit clear what are the first law of motion. The first law of motion states that an object remains in the rest or the motion, wants to remain in the rest or motion until an external unbalanced force is applied on it. So this is what the first law of motion. Now here the word comes inertia. Inertia was used by Galileo Galilei. He also states the same. The Newton has derived from this idea. So what is inertia? The tendency to stay in rest or in motion with the same velocity, because when this bus is moving in the same direction with the same velocity, the force is not applied. External force is not applied on it. When the driver will just speed up the bus, then the force will apply and it will move faster. So in the uniform motion, does not change the speed. So in the uniform motion, the tendency to stay in rest or in the motion with the same velocity is called inertia. Due to this, the first law of motion is also called the law of inertia. Law of inertia. First law is also called law of inertia because what the Newton explained, the same explanation was given by Galileo Galilei, and it was the term inertia, particular term given by him. So inertia is the tendency to stay in rest or in the motion until the external force is applied on it. So this is what called inertia. Now we come to the second law of motion. It is pretty bit difficult but very interesting. A small formula will derive from this very big formula. Now we will learn about the second law of motion. But before going to that, let us discuss what is momentum. Because momentum is important for the second law of motion. When we will understand the momentum, then it is easier to understand the second law of motion. Now we will learn about momentum. Before going to momentum, I want to tell you something that inertia and mass are directly proportional to each other. The inertia and the mass are directly proportional to each other. Inertia is directly proportional to mass. When the mass is higher, mass is large, then inertia will also be higher. When inertia and mass are low, when the mass is low, very light object, then inertia will also be low. Let's see an example. This is a truck loaded with very heavy objects. So when you try to push the truck, will it move? No. Because mass of the object or mass of the truck is higher. So the inertia will also be higher. It will remain in rest. It will not move with our push. So for moving this truck, we have to apply more force, and which is done with the help of engine. So mass is directly proportional to inertia. When the mass is light, suppose this is a chalk, the mass is very light, very low mass. So when I will push it, then it will move easily. So this is what called inertia. Inertia is directly proportional to mass. Now we come to the momentum. What is momentum? Momentum is the product of mass and velocity. The product of mass and velocity is called momentum. The product of mass and velocity is called momentum. Very simple. So what is the SI unit of momentum? The SI unit of mass is kg and the SI unit of velocity is meter per second. So kilogram into meter per second is the SI unit for momentum. SI unit kilogram into meter per second. This is the SI unit of momentum. Easy? So what is momentum a scalar quantity or vector quantity? Obviously it is a vector quantity. It requires the direction along with the magnitude. It requires direction. In which direction the object is having the momentum. it is important. So we have to mention the direction also in momentum. Momentum is a vector quantity. Vector quantity. Vector quantity. Momentum is vector quantity. Now we will learn about the second law of motion. So the second law of motion states that the change in momentum is directly proportional to the applied force. Change of momentum is denoted by small p. So change in momentum is directly proportional to the applied force. Change of momentum is directly proportional to applied force. Now, how can we write in the form of formula? Let's see. Change in momentum. What is the change in momentum is equal to P2 minus P1. Change in momentum. Greater momentum minus smaller momentum. P2 minus P1 upon T is directly proportional to force. Force is directly proportional to change in momentum upon time. So, force is proportional to change in momentum. How can we write this? Momentum is equal to mass or a mass into velocity. Product of mass and velocity is called momentum. So, mv minus mu upon t. M mass, v final velocity, m mass and u initial velocity. So, force is proportional to, we can take mass as common. So, m v minus u upon t. Now, force, mass, final velocity, initial velocity and time. So, force is proportional to. Now, what is v minus u upon t? Correct, acceleration. So, m into a. So, by removing this proportionality sign, we have to put a proportionality constant. Force is equal to, we can write K and A. K is the proportionality constant here. By removing this proportional sign, we have to write K. And the value of K is 1. So, force is equal to 1 into ma. So, what is this? Force is equal to ma. This is the formula for second law of motion. Where F is equal to ma. F is force, m is mass and a is acceleration. Force is equal to mass into acceleration. And though it was just discovered by the Newton, so the SI unit of the force is equal to ma, or the SI unit is Newton. SI unit Newton, which is denoted by capital N. So, SI unit is Newton. The formula for second law of motion is F is equal to ma. So, this is the most common formula and important formula for the second law of motion. Now, we'll come to the third law of motion. Now, third law of motion. The third law of motion states that every action has equal and opposite reaction. Every action has equal and opposite reaction. Suppose that you are swimming in a pool. What happens? You push the water from your hands like this. you are applying a force. So what happened? In the reaction, the water applied the force on you. That's why you move forward. You apply a force backward, then the motion from the water is applied forward. Another example is bullet. When you fire a bullet from a gun, what happens when you fire? Then you just little bit move backwards. Why? Because bullet move forward, then the reaction of the bullet is applied on the gun. That's why you move backward. This was the third law of motion. The third law of motion states that every action has equal and opposite reaction. Every action has equal and opposite reaction. Now we will come to the examples of first, second and third law of motion. So we will see the examples of first law of motion. The first law of motion can be divided into three parts. The inertia of motion, inertia of rest and inertia of direction. Inertia of, this I is for inertia. Inertia of rest, inertia of motion and inertia of direction. Inertia of rest, motion and direction. So we will see the examples of all the three. Inertia of rest. The objects wants to be in the rest. They don't want to move. This is called inertia of rest. Inertia of motion. The objects wants to be in motion. They don't want to become in the rest. They don't want to become in the rest. Now inertia of rest. The examples of inertia of rest are when you are sitting in a bus and the bus is not moving. It is in the state of rest. Then you are also in the state of rest. When the driver suddenly starts the bus, then you move backwards. Why? Because the bus is in the motion. The bus starts to move forward, but your body wants to be in motion. So your body wants to be in the rest. That's why you move backwards. The bus moves forwards, but we want to be in the rest. That's why we move backwards. So sudden motion of bus. There are many examples of inertia of rest. Suppose that a branch is in the rest, but when the air just very thin branch, when the air just blow with the high velocity or speed, with the very high speed, the air strikes the branch. Then what happens? The branch wants to be in rest, but the leaves also wants to be in rest, but what happens? Because of the motion of the air, they have to move. So they don't want to change their state of rest, but due to the air, very high moving air, they just start moving. So this was the example of inertia of rest. Now inertia of motion. The objects are still moving. You are sitting in a bus and the bus is moving. Your body also moves along with the bus. But what happens when the driver just suddenly brakes up the bus? Then what happens? You move forward. Why? Because your body wants to be in motion. But the driver suddenly brakes up the bus. Then bus became in the rest, but your body wants to be in motion. That's why you fall front in the front or forward. So this was the example of inertia of motion. Now inertia of direction. The objects wants to be moved in that particular direction. They don't want to move here or there. You are just cycling. You are riding on a cycle and the water is filled in the mud, with the water is filled in the shallow ground. So what happens when a car or your cycle moves on that puddle? What happens? The water comes out. The water splits up. Why? Due to the inertia of direction. Due to inertia of direction, your cycle is moving in this direction, but the mud will split here in this direction. So this is the inertia of direction. Now we will come to the examples of second law of motion. The second law of motion examples are very simple. You have also noticed in the cricket match, when the batsman strikes the ball or hits the ball, then what happens? The fielder catches the ball. So instead of catching like this, he moved the hand like this. Why? He don't want to just show the style in front of everybody, but he wants to get less effort, the less force applied by the object or the ball. Why? When the fielder will catch the ball like this, then it will hit very harder and he might get injured. That's why the time is increased. The time is increased. The time is increased. That's why the velocity of the ball decreases slowly. Velocity of the ball decreases slowly, not suddenly. When the ball will come and he is just taking a catch and he does not move the hand like this, then what will happen? He might get injured in his hands. That's why he just catch the ball and increase the time to reduce the force applied by the the fast moving ball. That's why he don't get injured. He is not doing in this style, but it is a scientific logic. So third law of motion. The examples are very common in our daily day-to-day life. So when we are sitting on a boat and when we just when we move away from the boat, so the boat move backward. Why? We are pushing our body forward. We are stepping forward, but our body move the boat backwards. The action has equal and opposite reaction. So in the reaction, the boat moves backward and we move forward. So these were some examples of three laws of motion in the common. Now we will come to the law of conservation of momentum. Now we will come to the conservation of momentum. The conservation of momentum states that the total momentum before collision and total momentum after collision remains same or constant. The total momentum before collision and total momentum after collision remains same or constant. Let's discuss how this momentum does not change. This is an object with mass A and this is an object with mass B. It is moving with the velocity, initial velocity UA and this with UB. This is the condition before collision. This is the condition on collision, mass A and mass B. This is the force applied by the object A to the object B. And this is the force applied by the object B to the object A. And this is the third condition after collision. This is the M, mass M, A. And this is the mass M, B. Moving with the final velocity A and this B. So let's discuss the formula how the conservation of momentum remains same. Conservation of momentum. The total momentum before collision and after collision remains constant or same. So what is the formula for momentum? Momentum is equal to m into v. So momentum is equal to m into v. This is the formula for momentum. So P is equal to, now what is m? ma. We are taking this object ma. What is the velocity? ua and va. So velocity is equal to va minus ua. This is the condition for the first object with mass A. With first object mass A and upon time. Upon time. So P is equal to ma, which is the mass of the first object, va, final velocity of the first object, and ua, initial velocity of the first object, and time. So P is equal to ma va minus ua upon t. This is the condition for the first object. What is the condition for the second object? So this is the condition for first object and this is for second object. So P is equal to mb, second object, mb vb minus va upon t. P is equal to mb vb minus va by t, time. Now, so what is P? What is this condition? The force applied by object A to the object B. From applied force from A to object B. So this is the condition. Instead of P, we can write F A B. Force applied by object A on the object B, and this condition we can write F B A, force applied by B to the A. So these are the both conditions. Now on combining both of them, let's see what happened. So MA VA minus UA upon T is equal to MB VB minus UB upon T. On combining both the equations, equation first and second. Now what happens? T to T cancel. Then MA, we can multiply this on this part. So MA VA, on multiplying this MA VA. Now minus from this to this MA VA. We can multiply this number to both. Now here MB VB minus MB, UB. From this. Now what happens? Let's see. Now after this we have to take this value as negative because we have studied that equal action has equal and opposite reaction. So this will give the reaction to the MA. That's why we have to take this whole value as negative. So MA BA minus UA is equal to minus VB minus UB. This is the condition now here. We will take negative because it will give the reaction to the MA. Now MAVA minus MAVUA is equal to negative MVB minus MVUB. Now we'll change the place. So VA. So we have to take this from this. So MAVA plus, because this will become negative and after coming to the opposite direction of equal to, it will become plus. MBVB is equal to, now minus MBUB minus MBUB. Now here this is minus, so it will come here to become positive. So plus MAVA. This is the condition now here, UA. This is the condition. So this is the condition here. As you can see, MAVA plus MVVB is equal to MVUB plus MAUA. Both the values are equal to each other, and we have studied that the conservation of momentum states that the momentum before collision and after collision remains same. What was the momentum before collision and what was the momentum after collision are equal to each other. As you can see here, when we shift this pole, then we can get the same value as here. So all the conservation laws, conservation of energy, conservation of mass, etc. All the conservation laws states that the conservation of that particular things remains same. The particular thing, suppose that we are studying the conservation of mass. So conservation of mass states that mass can neither be created nor destroyed because it is equal. As you have already studied in the chemistry, the reactants are equal to the products. Why? Because mass remains same. So all the conservation laws are same. Now here we have completed our chapter, and I hope that you like the video. Hope you understand also. So thanks for watching this video.